Welcome back to the channel. If you ever wanted to see what truly remarkable Colorado silver ore looks like when it is cut wide open as a giant slice of vein, then you are going to love this video. This is a big, heavy slab of ore from the Creede District, and it is the kind of piece that lets you read the mine's history and the geology at the same time. Stick with me, because this is not just a specimen tour. It is a full high country silver story with mineralogy, geology, and the mining that chased this stuff underground. And before we get into it, hit like, subscribe to the channel, and ring that notification bell so you don't miss the next video. Today, we are in Colorado, in Mineral County, in the legendary Creede District, at the Bulldog Mountain Mine. This is a huge slab of chunky silver metal with lesser acanthite and baryte, and it is a large sawn slab with a lot of surface area to study textures. The width of this behemoth is 24 centimeters, and the height is 17.5 centimeters. This slab was professionally cut on a huge saw at a width of 1 centimeter throughout, and the mass is 1.3 kilograms. This slab is estimated to contain at least 30 ounces of silver, which is a jaw-dropping amount of precious metal in a single specimen. And as we do the slow tour of the slab later in this video, I want you to watch how the brightest metal and the darkest sulfide zones track along distinct bands and borders, because that foreshadows the geology lesson about repeated pulses of hydrothermal fluid and the way veins build themselves over time. Let us get things going by switching over to the map and orienting ourselves to the location of Creede and the Bulldog Mountain Mine in Colorado. So, we will start out by zooming into the United States and onto the great state of Colorado. Then, we will move down into the southwestern corner of the state to the San Juan Mountains again, a rugged range of volcanic highlands, deep canyons, and broad valleys. Moving in closer, we see the near symmetry of Snowshoe Mountain, which is the resurgent dome of the Creede caldera. This hints at the volcanic origins that are responsible for so much of the precious metal deposits in this corner of Colorado. Now, we're zooming in a little closer to town of Creede, one of the most famous late-era mining camps in the American West, known first and foremost for silver. Okay. Now we are going to transition to 3D and center on the rugged canyon just north of Creede, the kind of weathered topography that made underground mining both possible and brutal. The Bulldog Mountain Mine was just one of many silver mines in and along this canyon, and the main portal sits just to the northwest of town. Even before you talk about ore grades, you can feel why this district built a reputation. Hard rock, high elevation, long winters, and mines that had to be engineered into the mountainside to reach veins that could be extraordinarily rich. Alright, now that we have a good sense of where this slab was originally cut from the vein material mined underground in the Creede District, let us examine the specimen itself and break down what we are looking at. At first glance, the slab reads as a bold, high-contrast map of minerals. You have broad pale zones that look chalky white to light grey, and you have darker grey to nearly black zones that form patches, bands, and smudgy borders. Then, woven through those zones, you have areas with a distinctive metallic look. Not bright chrome like fresh steel, but a silvery grey sheen that catches the light differently than the gangue. That is exactly what you would expect from a silver-rich piece where some of the silver is native metal and some is tied up as silver sulfide. Let us start with the gangue because it tells you how the vein opened and filled. The white mineral is baryte, and it was a common gangue material in the Creede District mines. Baryte is barium sulfate, and in many epithermal silver systems, it can form thick, pale masses that look almost blocky or sugary when cut. On this slab, those white areas have that dense, matte, pale character that is very consistent with barite-rich vein fill. In a few places, you can even see subtle boundaries and banding where one pulse of pale material ends and a different texture begins, like a frozen record of repeated mineral deposition. Now look at the darker zones. That material is acanthite, which is silver sulfide. Acanthite commonly appears dark grey to black, and in rich silver veins it can occur as masses, blebs, and streaks that concentrate along specific bands. On this slab, the darker grey fields are exactly where your eyes want to go because those are the zones that most often host the highest silver grades. Some of these darker areas look like they have diffuse edges into the lighter gangue, and in other places they form sharper contacts like the vein filled, cracked again, and then got sealed by a new generation of material. Importantly, acanthite is about 87% silver by weight, so it adds a lot of value to this already magnificent specimen. And then there is the silver itself. Even when native silver is not mirror bright, it has a unique metallic reflectance that stands out against baryte and acanthite. On these faces, you can spot areas where the surface looks more metallic and more reflective, especially along transitions between pale gangue and darker ore bands. In a lot of silver ore, especially from classic underground districts, native silver can also tarnish and dull over time, so the metal may present as a subdued silvery grey rather than a bright white flash. The key is that metallic luster and the way it sits in the vein texture, often along edges, seams and bands where fluid chemistry shifted. One thing I really like about this slab is that the saw marks are still visible in places, and that actually helps you read the material honestly. You can tell you are looking at a true cross-section through vein fill, not a surface coating. That matters, because when a slab is this size, the mineral zoning is not random. It is the architecture of the vein. The ore is telling you where fluids moved, where they paused, where they boiled or cooled, and where chemistry flipped, from depositing barite to depositing sulfides and precious metals. Now let us tie that back to what the label tells us about the mine workings. This piece is labeled from the Bulldog Mountain Mine. 67 stope, from the 9,360 to 9,500 levels. In mining terms, a stope is the area where ore was actually removed, the mined-out void that follows the ore chute. And a level is a horizontal working horizon, often named by elevation. So those levels suggest this ore came from a specific vertical slice of the mine where the vein was productive across that range. That is a really cool detail, because it hints that this slab represents material from a defined ore zone, not just a random grab. And it just so happens that the 67 stope is famous for these nearly solid blocks of silver metal that were removed from the mine. Specimens just like this one grace displays in private collections and museums around the world. Okay, so what kind of deposit are we looking at here? Geologically speaking, Creede is famous for epithermal silver mineralization related to volcanic activity. Epithermal simply means the ore formed at relatively shallow crustal levels from hot hydrothermal fluids, not the deep roots of a porphyry system, and not the high-pressure metamorphic environment of an orogenic gold vein. In plain language, these are hot fluids moving through fractures in volcanic terrain, depositing minerals as conditions change. The Bulldog Mountain Mine, like much of the Creede District, fits beautifully into a silver-rich epithermal vein model where structure is everything. Faults and fractures create open space. Fluids rise through that plumbing. Then, as pressure drops, as fluids cool, or as they mix with cooler groundwater, minerals precipitate. Baryte can drop out under certain chemical conditions, and silver sulfides like acanthite can concentrate when sulfur activity and temperature line up just right. And because these systems pulse, fracture, fill, fracture again, fill again, you get banding, repeated contacts, and all concentrated along specific horizons. That pulsing concept is the big takeaway you can see right on the slab. Those sweeping transitions between pale barite-rich zones and darker ore-rich zones are classic for a multi-stage vein. Think of it as multiple episodes of fluid flow, each one leaving behind a slightly different mineral recipe. One pulse might lay down a lot of baryte, another might bring a silver-rich, sulfur-bearing fluid that drops acanthite and native silver. Another pulse might reopen microfractures and smear metal along contact. The slab is basically a time-lapse of vein growth over time, frozen in cross-section. Now, let us talk briefly about why Creede matters historically, because this district is one of the iconic silver stories of Colorado. Creede is often remembered as one of the last great silver booms in the American West, and the district became famous for rich silver veins that could be extraordinarily productive. The mining here was classic hard rock underground work, drifting along veins, raising and stoping ore chutes, timbering where needed, and dealing with the constant challenges of ground conditions, water, ventilation, and the sheer logistics of moving ore in rugged mountain terrain. When you hold a slab like this, you are holding the exact kind of material that justified all that effort, the kind of ore that could carry serious silver value, concentrated into vein zones that miners could follow underground. From a collector standpoint, this specimen is significant for a few reasons that go way beyond look at the metal. First, it is from a classic district with strong name recognition, and the label information is specific enough to feel anchored to real mine geology and real workings. Second, the slab format is perfect for education, because you can actually see mineral zoning and vein architecture across a big face. Third, the mineral association is textbook for silver ore, native silver with acanthite, hosted with baryte gangue. That is not just aesthetically interesting, it is a reference piece for how epithermal silver veins can look when they are cut and displayed as a cross-section. And if you have spent time around precious metal specimens, you know there is a big difference between isolated crystals and true ore. Crystal specimens are amazing for mineral beauty and crystallography. Ore slabs like this are amazing for telling the full story. The fluids, the fractures, the banding, the chemistry, and the way mines actually encountered the deposit underground. This is the kind of piece you can point to and say, this is what a silver vein looks like on the inside. Alright, let us wrap it up with a quick summary. This is a large silver ore slab with acanthite and baryte from the Bulldog Mountain Mine in the Creede District of Mineral County, Colorado. A big, information-rich cross-section through epithermal vein material, and it is estimated to contain at least 30 ounces of silver. The pale barite-rich gangue, the darker acanthite-rich zones, and the metallic silver horizons all work together to show you how these veins grew in pulses and how structure controlled ore deposition. If you enjoyed this deep dive, smash that like button, subscribe to High Country Gold and Silver, and ring the notification bell. And drop a comment telling me what district, mine, or mineral you would like to see featured next. Thanks for watching.